All right. Hey, geometry. So today, well, we have these week 2 nodes that we've been working on, and we already did the first two transformations. We did translation and reflection. So today, the last one we have to do is rotation. And rotation is pretty simple. It's pretty self-explanatory. And in this class, I don't believe we'll be seeing any rotations around anything other than the origin. So as long as we know our rules for rotating around the origin, then we're good. And most of the things we're going to see in this class are going to be pretty similar, with rotation at least. Okay, so first we have a definition of a rotation. So hopefully you guys know what a rotation is, but the geometric definition of a rotation is going to be, we'll call it a transformation in which a figure is moved around a fixed point. And in this class, I don't believe we're going to see rotation around any point other than the origin. Okay, so here we have rotations always go in the counterclockwise direction unless otherwise stated. For those of you who don't know, counterclockwise is this way around. Just because I know some people can't remember which one is clockwise, which one's counterclockwise, or they just have never learned. So that's fine. Yeah, so unless it says clockwise, you're going to go counterclockwise. So in rotation, we have these two new vocab words. We have the center of rotation, which is the fixed point from which a rotation is performed, which is most often the origin. So you can see in this image, they are rotating this triangle around the origin. And it looks like, because this one's labeled A, B, C, and then D, it looks like they actually rotated that one clockwise, which goes against what they just said, but you know, it usually goes counterclockwise. Okay, anyways, the angle of rotation, which is the number of degrees a rotation is performed, usually paired with a direction. And in this class, the angle of rotations we're going to be seeing are most likely going to just be multiples of 90. So we're going to see 90-degree rotations, 180-degree rotations, 270-degree rotations, and 360-degree rotations. So yeah, the number of degrees or rotation is performed usually paired with the direction, and it'll either say like counterclockwise or clockwise sometimes. And if you don't see anything, just assume it's counterclockwise. And then here we have our little table, which gives the rules for rotating an object around the coordinate plane. So if you have like a 90-degree rotation counterclockwise, you're just going to take your x, y of whatever point it is and flip it, make the y negative. So we can see that it goes from x, y to negative y, x. A 180-degree rotation is going from x, y to negative x, negative y, which is also the exact same thing as a reflection about the that line y equals negative x, as we learned. Yeah. Sorry, I was just thinking about something. And then we have a 20-degree or 270-degree rotation counterclockwise, goes from xy to y negative x. So in this one, the x turns negative, or you flip them and the x turns negative. With 90, it was flip them and the y turns negative. And then 360-degree rotation, xy to xy, because a 360-degree rotation is just coming right back around to where you started. And if you were to see clockwise on a problem, you would just switch the 90 and the 270. If you were to go clockwise, no matter which way you went, a 180-degree rotation would just end up right back at the same place. A 360-degree rotation would end up right back at the same place. But with a 90, that is the same as a 270 degrees clockwise, and a 270 counterclockwise is the same as 90 clockwise. Okay. So, and typically, like, I'm pretty sure that anything I give you in this class, you would have this little like cheat sheet thing available. So you don't need to like memorize these, but it's good to know them just so you can like do them at the snap of a finger. Okay, and then they have the same table again, just in case. All right. So, here we have quadrilateral. This is how you'll typically see a rotation problem. It'll have like quadrilateral ABCD, which names the shape that we're rotating, and then it'll have a semicolon and 270, which means we are rotating it 270 degrees counterclockwise, since it doesn't specify which direction we're going. And it just, like this one is pretty much already filled in for us. We just have to draw in the shape. But the rotation image of xy is going to be y negative x because of what it says right here with the 270 degrees rotation counterclockwise. And then it says find the coordinates of the vertices, and the coordinates are already given to us. So we are going to draw in those coordinates. So this point A is mapped onto A prime, and A is at 0, 2. A prime is at 2, 0. So A prime is going to be right there. A prime. B, which is originally at 1, 4, is going to be mapped onto the point 4, negative 1. So 4, negative 1 is right there. So this is B prime. C, which is originally at 4, 2, is mapped onto the point 2, negative 4, because again, you just switch the x and the y, make the y negative. Or make the, well, I guess the x, but the new, which is the new y value, I don't know. The second one, you make that negative. So it goes from 4, 2 to 2, negative 4, 2, negative 4, right there. So that's my C prime. And D prime started at 3, 1. So now, or D was at 3, 1. So D prime is going to be at 1, negative 3, which is right down there. And there we go. And if I connect these points, ooh, that should not have been a curved line. There we go. Yeah, that's about right. And we can see how that looks like a 270-degree rotation about the origin. So 270 degrees is going to be like there. So they took it, rotated it all the way around. And typically in class, like if you guys were physically here, I would like have like cutouts, and then we'd just be like literally moving them around the origin, so we'd be able to see the physical rotations and learn from that. But you know, we're not in class, so oh well. Okay, on to the next one. So this one, we actually have to fill it in. So they have this triangle KLM, and they specify 180 degrees. And they don't specify the direction, so we're going counterclockwise. And either way, with 180, 180 is one of those ones that it doesn't matter which way we're going, because it's going to end up at the same place either way. So the rotation image of XY, when we move it 180 degrees, is going to be, according to the table I had up here, 180 degree rotation when from XY to negative X, negative Y. So it's going to be negative X, negative Y. And it says find the coordinates of the vertices of the image. So we're just going to make both the X and the Y negative, and we don't need to flip them at all. We just make them negative. So I have 2, negative 1. Making them both negative, or I guess a better word is like changing the sign. So from 2, we go to negative 2. From negative 1, we go to positive 1. So the point K, which is at 2, negative 1, maps onto the point K prime, which is at negative 2, 1. And I can put that on here, so negative 2, 1. And that's my K prime. All right, up next, I have the point L, which is at 4, negative 1. And again, I just make both of them negative. So 4 turns into negative 4. Negative 1 turns into positive 1. So the point L prime is going to be at negative 4, 1. And that's my L prime. And finally, I have this point M, which is mapped onto M prime. M is at 1, negative 4. Switch the signs on both of them. 1 turns into negative 1. Negative 4 turns into positive 4, which means M prime is at negative 1, 4, which is right up here. So this is my M prime. And now to just make this into a triangle, I'm going to connect my points. And there we have this triangle, KLM, was mapped 180 degrees onto this triangle, K prime, L prime, M prime. I was about to say something, but I forget what it was. Oh, these like coordinates that we have like prime, so like K prime, L prime, and M prime. So sometimes if we have like 2 transformations, if we do like a rotation and then a reflection, or a rotation and then a translation, or something like that, you'll see like M double prime or K double prime. And if you just see 2 apostrophes with it, that means it was like translated or transformed twice. Oh, it says predict. We already did it. Oops. So KLM already lies in quadrant 4. And when it's rotated by 180 degrees, it's going to lie in quadrant 2. And then, yeah, we already plotted KLM to graph the image. Yeah. All right. This is another way that we might see it. So when we had our reflections, those were represented by like a lowercase r, and uppercase R means rotation. So lowercase is reflection, uppercase means rotation. So here we have, it asks us to draw the image of the figure under the given rotation. So this is a 90-degree rotation of this triangle PQR. And according to my little cheat sheet, a 90-degree rotation, we have xy turns into negative y, x. So I'm going to fill that in. So xy turns into negative y, x. So P, we got to fill in the points too, it looks like. P is already at the point 2, 1. So 2, 1. And when we map that, P prime, it's going to go from xy to negative yx. So our y is 1, so negative y is negative 1, and then the x stays positive, which means P prime is going to be at negative 1, 2. So I can plot that. So negative 1, 2, it's right there. What is going on? There we go. So yeah, that's my P prime. From Q to Q prime, let's see, Q is at the point 4, 1. So when I map this, the y value here is 1, which means my x value of Q prime is going to be negative 1. And the x value of Q is 4, which means the y value of Q prime is 4. So negative 1, 4. Here is my Q prime. And finally, we have R, so R prime. And R is at, what is this? This is 4, negative 3. So we flip the coordinates and then make the y value negative. So the y value here is negative 3. When I change the sign on that, it is going to be positive 3 for my new x value. And then my new y value is going to be 4 because that one stays positive. So it went from 4, negative 3 to 3, 4. So let's see, 3, 4 is right there, and that is my R prime. And now I just need to connect the points. And there we have a 90-degree rotation of this triangle PQR onto this new triangle P prime, Q prime, R prime. Okay, so let's see. Oh yeah, that's the last page, it looks like. Okay, so the next one, we have a 270-degree rotation of this quadrilateral DEFG. And according to my little chart up here, a 270-degree rotation is going to be from xy to y negative x. So it's basically just going to be the opposite of what it was here because we still flip the coordinates, but instead we're making the x value negative instead of the y value. So it goes from xy to y negative x. All right, so let's see. Starting with the point D, D is at negative 3, 1. So when we change this to y negative x, let's see, my y value here is 1, and my x value is negative 3. So negative 3 is positive 3. So that means D prime is at 1, 3. Which is right up there. Okay, my next coordinate is E, which is at, that looks like negative 1, negative 1. My y value here is negative 1, which means the x value of E prime is negative 1. And my x value here is negative 1, which means the y value of E prime is positive 1. So that goes from negative 1 to negative 1, 1. Right there. my E prime is right there. Up next, we got F prime, or F to F prime. F looks like it is at, what is that? -1, -4? Yeah, I think so. Okay, so -1, -4. The y value of f is -4, meaning the x value of f prime is -4. And the x value of f is -1, meaning the y value of f prime is +1, which means that f prime is going to be at -4, 1, which is right there. Okay. And finally, this one is a quadrilateral, so it has a fourth point. So this point G, it looks like that is at, what is that? Is that -3, -3? I wish they'd labeled this, the negative values on this y-axis. But yeah, that looks like it's -3, -3. Yeah. So the y value of G is -3, meaning the x value of G prime is -3. And the x value of G is -3, meaning the y value of G prime is +3. So -3, 3. Which is right there. G prime. And I just have to connect these points. Okay, there we go, G prime. And yeah, I believe that's all we have to do. Okay, continuing on. Yeah, continuing on. It says determine the direction, clockwise or counterclockwise, degree, and center of rotation. So here we have, is this JKV? Yeah. So this is triangle JKV down here, and it's being mapped onto J prime, K prime, V prime. And let's see, so we have, I'll just pick a point, I'll go with J. So J, it starts at, is that -1, -2? And it is mapped onto J prime, which is at 1, 2. So basically, we just have to say like which of our transformations this, or which of our rotations this was. And from -1, -2 to +1, +2, that would be a 180-degree rotation. And we can see this was a rotation about the origin because it's almost always going to be a rotation about the origin. Like I said, I don't think we're going to see any rotations that aren't about the origin in this class. So we can also see that this was a 180-degree rotation just by the way that like it looks like it went like not just up here, but not just like up to the first quadrant, it went to the second quadrant. So it was mostly in the fourth quadrant, and then it went 2 quadrants around. So it's like in the second quadrant now, which means it was a 180-degree rotation. Okay, so determine the direction. Well, 180 degrees is one of those ones that it doesn't matter what direction you go. So we'll just say counterclockwise because it's almost always counterclockwise. Degree, well, we just said that was 180. And center of rotation is the origin. Okay. And the next one we have to do is this quadrilateral BUYK, or BKYU, I guess. BUYK, BKYU, doesn't matter. Anyways, yeah, we're rotating this quadrilateral, and it said the first thing we have to do is determine the direction. So almost always the default is going to be counterclockwise. So we're just going to assume it's counterclockwise. Next, we have the degree. So I'll just pick a point. I'll pick, maybe B isn't the best point to go with here. We'll go with U. So U starts at 2, -2. No, U isn't the best point to go with either. Sorry. What's a good one? K. So K starts at 5, 3. And it maps onto K prime, which is at -3, 5. So let's figure out which of our transformations this is. And looking up at this thing here, it went from, what was it? It was xy to -yx. So xy to -yx is a 90-degree rotation. So it was 90 degrees. And we can also kind of tell that as 90 degrees because this figure is mostly in the first quadrant, and after it's mapped, it is mostly in the second quadrant. So that was just one quadrant over, meaning it was 90 degrees, or one quadrant like up, I guess, because you go from 1 to 2. If you were going from 2 to 1, that would be a 270-degree rotation. Okay, counterclockwise, 90 degrees, and once again, the point of rotation, or center of rotation, is the origin, because we're not going to see anything that isn't about the origin in this class. Okay, so if you've made it this far in the video, I appreciate that. And this is the end of the week 2 notes. There is no assignment for this week. I feel like I've been giving you guys a lot of work, and I know some people have been overwhelmed, so please use today to get caught up on things if you're behind, and if you're not, great. I appreciate you being on task and able to find your work. And I know some people have had issues finding the work, so let me know if you do. All right, thanks y'all.